This video is on Unit 1, Chapter 3, Lesson number 1. Chapter 3 is on systems of equations, and in Lesson number 1, we're going to focus on solving systems by graphing. What is a system of equations? A system of equations, in your notes here, says two or more linear equations. I would like to point out that they don't necessarily have to be linear, but that is what we're going to focus on in this first lesson. When you have two linear equations, there are three different things that can happen here. So under types of solutions, what you need to focus on here is exactly what might happen with our lines as we go solve these systems. If your two lines hit each other at one point, that creates one solution. So they are intersecting at one point. There might be a situation in these problems where the lines are parallel to one another, which means they do not hit. And then you might have the same line. So what we're looking for when we're solving systems of equations is where do they hit? That's the solution. Where do they intersect each other? So if they hit each other at one point, that creates one solution, and that solution is the ordered pair xy. The reason why the next situation is no solution is because if I'm looking for where they hit each other or where they intersect and they're parallel, they don't hit each other at all, that creates no solution. And then when you have two lines that graph into the same exact line, then that means they intersect everywhere, creating an infinite number of solutions. So again, to solve a system, you are looking for where do they intersect. Let's add that. The solution to the system is the point of intersection. Actually, I'm going to put an S here. Because it could be more than one point. All right, now let's look at the steps solving by graphing. Step number 1 says to express both equations in slope-intercept form, which is y equals mx plus b. Step number 2 is to graph. Those of you that are using your own calculators, you may need to hit zoom 6 to go home, to go back to that standard size window. Step number 3 says hit second in calc. You're going to select number 5, which is the intersection, and then you're going to need to hit enter 3 times. The intersection will be at the bottom of your screen. Step number 4 says to express your answer as an ordered pair, x, y. And then the little asterisk here says you can also look on the table of ordered pairs for the solution, find any two y coordinates that are the same, express your answer as an ordered pair. So let's look at example number 1. Both equations are already in slope-intercept, so I'm going to pull up my graphing calculator. And I'm going to put both of those equations into the y equal. So go to y equal on your calculator. We're going to put in both of those equations here. The first one is negative 5/3 x minus 6. So I'm going to pull up a fraction, negative 5/3. The x, remember, is next to alpha, minus 6. I'm going to hit enter and go down to y2 and put in the 1/6 x plus 5. I'm not sure why that skipped down a line. X plus 5. Now I'm going to hit graph. And what you're trying to look at here is, do they intersect at one point, no points, or multiple points? Well, the red line and the blue line are going to intersect at one point, and I've got to figure out what that one point is. Now, there's two different ways that I've said you can do this. The first one is to hit second trace, which is calc, select number 5, which is intersection, and then hit enter, enter, enter. And it tells you at the bottom of the screen here that the intersection is at negative 6, 4. So the solution to number 1 is negative 6, 4. The other way to do that is to look at the table of ordered pairs. So hit second graph, which brings up the table of ordered pairs. You'd have to kind of go looking through here. You're looking for the blue and the red to be the same number, and they're not the same here. We know that the answer is negative 6, 4. So if you look here on my table, negative 6, 4, the 4 is the same in the blue column and in the red column. That's what tells me that that's the solution to the system. All right, let's look at example number 2. Number 2 says y equals 5 and y equals 2x plus 7. So we're going to put those both into the graphing calculator. Go back to y equal, clear out the old stuff. Y equals 5 is the first one. Y equals 2x plus 7 is the second. Graph. Again, these are going to hit each other at one point, and we've got to figure out what that point is. I'm going to hit second graph to see if I can figure it out from the table. And if you look here at negative 1, 5, you can see that the blue and the red both have the 5. So negative 1, 5 is the solution. Again, the other method is to hit second trace, number 5, enter, enter, enter. And there's your answer at the bottom of your screen. Looking at example number 3, 4, 5, and 6, these equations are not in slope-intercept. So what you're going to have to do first is you're going to have to change them to slope-intercept. So I'm going to take the 2y equals 8x plus 18, and I'm going to change it to slope-intercept by dividing everything by 2. And I get y equals 8x divided by 2 is 4x plus 18 divided by 2 is 9. And then I'm going to take the second equation, which is 24 plus 4y equals x. We need to get y by itself, so I'm going to move the 24 first. I'm going to subtract the 24, and I get 4y equals x minus 24. Now, when we go to divide everything by the 4 here, you get y equals, this is 1/4 x, 24 divided by 4 is a 6, so minus 6. So your two equations are there, y equals 4x plus 9 and y equals 1/4 x minus 6. Steps are the same. Go to y equal, clear the old, put in the new. So I got 4x plus 9 for my first one and 1/4 x minus 6 for the second one. Graph. And again, they hit each other in one spot. They hit each other one time. There is one solution. Second trace, number 5, enter, enter, enter. Negative 4, negative 7 is my solution. Example number 4, same kind of deal. We have to take both of these equations and move them around. So the first one just has a negative y. I'm going to divide everything by negative 1. And I get y equals positive x plus 6. I should be dividing all of that by negative 1, just FYI. The second equation says 3x plus 18 equals 3y. I'm going to just divide everything by this 3. And we get y equals x plus 6. Now, if you look closely at these, and I know they're kind of reversed from each other, but they both say y equals x plus 6. Well, if they both equal the same exact thing, they're going to be the same exact equation. This is what infinite solutions is going to look like. If I were to graph this, I mean, obviously they're going to be the same line. There's the blue, there's the red. So they hit each other everywhere. Remember that the solution to a system is where the lines hit each other. With this situation, they hit each other everywhere. So there's an infinite number of solutions. You cannot say all reals because not all reals work. For the next set, one of our equations is good. We just have to take the 3x plus 6y equals negative 12 and make it say y equal. So the first thing I'm going to do is subtract the 3x. And when we do that, remember you cannot combine the 3x and the 12. You're just going to bring both of them down. We're going to divide everything by the 6. And we get y equals negative 3 over a positive 6 is going to reduce to negative 1/2 x. And then negative 12 divided by 6 is a negative 2. So I got y equals negative 1/2 x minus 5 for one of my equations, and y equals negative 1/2 x minus 2. So let's put those in. And we got, again, alpha y equal, we need a fraction, negative 1/2 x minus 2. I'm going to put that one in first. And then the negative 1/2 x minus the 5. And graph. And what you should see here is, again, if we're looking for where the lines hit, these do not hit. This is what no solution looks like. There's no solution on that one. And last one, number 6. We're going to have to take both equations and move them around to make them say y equal. So I'm going to subtract the 6x. Divide everything by the negative 5. And we get y equals negative 6 divided by negative 5 is positive. It doesn't reduce, so we're just going to leave it 6/5 x. Negative 28 divided by negative 5 is going to be positive. Does not reduce, just leave it 28/5. The second equation says 7x plus y equals 22. And if we just subtract the 7x, we get y by itself. All right, so let's put that in. Go back to the calculator, back to y equal, clear out the old, and let's put in our two equations. So we got negative 7x plus 22. And then the other equation was y equals 6/5 x plus 28/5. And again, you can clearly see that these two lines are going to intersect at one point. Second trace, number 5, enter, 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 and you get the intersecting point of 2, 8. So that answer was 2, 8. Number 5, again, was no solution. Number 3 was a negative 4, negative 7. Number 4 had infinite solutions. Number 2 was negative 1, 5, and number 1 was negative 6, 4. So those are your notes for lesson 1 of chapter 3. Again, we will work on the assignment portion of this in class together.